My name is Kavita from Basic Chemistry Honors second year. Today's my chapter is carboxylic acid. Carbon compounds containing a carbonyl groups C double bond OOH are the carboxylic acid. The carboxyl groups consist of the carbonyl groups attached to the hydroxyl groups. Hence, it is named as carboxyl. Carboxylic acid may be aliphatic or aromatic depending on the group's alkyl or halide attached to the carboxylic carbon. Large number of the carboxylic acid are found in the nature. Some higher member of the aliphatic carboxylic acid as fatty acid occur in the natural fat as esters and the glycerols. Carboxylic acid serve as starting material for the survival and other important organic compounds such as anhydrous esters and basic amides, etc. Nomenclature and structure of the carboxyl groups. Nomenclature says carboxylic acid are almost the earliest organic compounds be isolated from nature. A large number of them known as then common names. Common names end of the suffix is acid and has been derived from the Latin or the Greek names of their natural sources. For example, formic acid was the first obtained from the red acetane, and Latin formic means ant. Acetic acid is from vinegar, Latin atanium means vinegar. Butyric acid from the racines butter, Latin is butyrium means butter. In the IPAC system, aliphatic carboxylic acid are named by the replacing ending E in the name of the corresponding alkane with an oic acid is numbering the carboxylic chain, the carboxylic carbon in the membered one. When naming the containing more than one carboxyl alkyl groups having carboxyl group is number 1 and the number of the carboxyl is indicated by adding the multiplicative prefix dicarboxylic acid, tricarboxylic acid, etc. and the names at the parent chain. The position of the COH are indicated by the Arabic numerical before the multiplicative prefix. Some of the carboxylic acid have the common name and application name as listed below. First is the formic acid, is application name methanic acid, is acetic acid, application name is ethanic acid. Third is propanoic acid, application name is propanic acid. Fourth is butyric acid, application name is butanoic acid. Isobutyric acid, that is 2-methyl propanoic acid, is oxalic acid, is the ethanic dioic acid, is the malonic acid, that is the propanoic acid. Succinic acid, that is the butanodic acid. Butyric acid is the pentadioic acid. Apidic acid is the hexanodic acid. The tricarbolic acid or carboxylic acid is the propane 1,2,3 dicarboxylic acid. What is the benzoic acid? That is the benzocarboxylic acid or benzoic acid. Next is the phenyl acetic acid, that is the 2-phenyl ethanoic acid. And is the phthalic acid is the benzene 1,2 dicarboxylic acid. Structure the carboxyl groups. In carboxylic acid, the bonds of the carboxylic acid lies in the plane and separated by the about 120 degree. The carboxylic acid is less electrophilic than the carbon because of the possible resonance structure shown below. Method of the preparation of the carboxylic acid. Some important method for the preparation of the carboxylic as follows. From primary alcohol and aldehyde. Primary alcohol readily oxidizes to the carboxylic acid with common oxidation agents such as the potassium permanganate in the neutral acidic or alkyl media and by the potassium dichromate and chromium trioxide are acidic zone reagents. RCH2OH then from the reaction with the alkanes KMnO4 or H3O positive then form the carboxylic acid. 1-dianyl is with the Jonic reagent CrO3 negative CH2 SO3 then it form the diionic acid. The carboxylic acid is also prepared with from the aldehyde by the mild oxidizing agent. Second is the from alkyl benzenes. Aromatic carboxylic acid can be prepared by the vinous oxidation. Alkyl benzenes with the chromic acid or acidic or alkyl potassium permanganate. The entire side is oxidized To the carboxylic acid permanganate, the entire side is oxidized by the carboxylic is respective to the length of the side chain. Primary and the secondary alkyl groups are oxidized in the manner while tertiary group is not affected. Suitably substituted alkenes are oxidized by the carboxylic acid with the oxidizing agents. And then the toluene react with the camena for catch and heat, then it forms the benzoic acid. You have to see other reactions. From the nitrile and amides, nitriles are hydrolyzed to amides, then acid in the presence of the H positive or OH negative as a catalyst. Mild reaction conditions are used to stop the reaction at the amide stage. Then amide then it form the ethanoic acid. Benzene amide then it convert into the benzoic acid और NH3 इनमें से अमोनिया से बाहर निकल जाएगा and the side products. What is the from the Grignard reagent? Grignard reagent react with the carbon dioxide, dry acid to form the salt and the carboxylic acid, which is in turn give corresponding carboxylic acid after acidification with the mineral acids. In the RMGX plus O double bond C double bond O die in presence of dither form the RC double bond O single bond with OMGX, then it react with the H3O positive, then it form the carboxylic acid. As we know, the Grignard reagent in the nitriles can be prepared from the alkyl halides. The above methods are useful for converting alkyl halides into corresponding carboxylic acid having one carbon atom more than present in the alkyl halides. From acyl halides and anhydrous acyl chloride with hydrolyzed with water gives carboxylic acid or more rapidly hydrolyzed with aqueous base to give the carboxylate ion, which ion is acidified, provide corresponding carboxylic acid, and hydrolyzed on the other hand are hydrolyzed to corresponding acids with water. RCOCl then it form the carboxylic acid RCOH and इसमें क्लोरीन बाहर निकल जाएगा. इसमें बेंजोइक एसिड और इथेनोइक एसिड एट लास्ट बन जाएंगे. From the stress acidic hydrolyze of stress gives directly carboxylic acid, while base hydrolyze gives the carboxylate, which an acidification gives the corresponding carboxylic acid. Ethyl benzoate then it forms the equilibrium with the benzoic acid. Ethyl butanate then react with the NH, then it forms the butanoic acid. Here to some reactions effect. Example number 12.5. इसमें ब्यूटेन वन ऑल इस जोन एजेंट्स के इसमें बन जाएगा ब्यूटोनिक एसिड. सेकेंड इज द बेंजोइल अल्कोहल, देन इट फॉर्म react with HBl, then form the benzyl bromide, then it react with the KCl, then form the benzyl cyanide. और इसमें हम H3O पॉजिटिव और इसे डाल के हीट कर देंगे, then form the phenyl ethanoic acid. That is the 3-nitrobenzoyl bromobenzene, इसमें Mg ethers डाल के 3-nitrobenzoic acid इसमें मिल जाएगा हमें. What is the 4-methyl acetophenone, then it form the dipotassium benzene 1 for dicarboxylic acid, then इसमें dilute H2SO4 से benzene 1 for dicarboxylic acid tetraphtalic acid बन जाएगा. इसमें नेक्स्ट इज साइक्लोहेक्सेन, इसमें क्या है MnO4 और H2SO4 हीट डाल के हीट कर देंगे, then it form the hexane 1 dioic acid. नेक्स्ट इज द ब्यूटेनॉल, इसमें मोनोलिकल AgNO3 डाल के टोल्यून से डाल के इसमें कर देंगे, तो इस ब्यूटेनोइक एसिड हमें मिल जाएगा. फिजिकल प्रॉपर्टीज. Aliphatic carboxylic acid to the 9 carbon atom are colorless liquids at room temperature with unpleasant odor. The higher acid are wax-like solid and they are partially odorless due to the lower volatility. Carboxylic acid are higher boiling liquids than aldehyde ketones or even alcohols, so the comparable molecular mass is due to the more extensive association of the carboxylic acid molecules through the intermolecular hydrogen bonding. The hydrogen bonds are not broken completely even in the vapor phase. In fact, the most carboxylic acid exist as dimer in the vapor phase or in the aprotic solvents. Simple aliphatic carboxylic acid having up to 4 carbon atoms are miscible in water due to the formation of the hydrogen bond with water. The solubility decreases with increasing number of the carbon molecules. Higher carboxylic acids are partially insoluble in water due to the increase in hydrophobic interaction of the Carbon part benzoic acid, the simplest aromatic carboxylic acid nearly insoluble in cold water. Carboxylic acid are also soluble in less organic solvent like benzene, ether, alcohol, and chloroform, etc. Chemical reactions reaction involving cleavage of the OH bond, acidity metals and alkalis. The carboxylic acid like alcohols involve halogen with the electropositive metals from the salt and alkanes similar to the phenols. However, unlike phenols, they react with a weaker base as the carbonates and the hydrocarbonates to remove the carbon dioxide. The reaction is used to detect the presence of the carbon in organic compounds. Carboxylic acid is associated in water to give the resonance stabilized carboxylate anion and hydronium ion. For the above reactions, the K equilibrium is the equilibrium constant and K is the acidization constant. For convenience, the strength of the acid is generally indicated by the pKa value rather than the Ka value. pK is equal to the minus log K. The pKa of the hydrochloric acid is minus 7. Hence, pK of the tricarboxylic is the strong carboxylic acid, benzoic acid, and acetic are 0.23 or 0.4.19 and 4.76 respectively. Similar, the pKa the stronger the acid is strong acid have the pKa value is less than greater than the 1 and the acid of the pKa value is between even and 2. 5. Consider the model is strong acid. Weak acid has pKa value between the 5 to 15. Extremely weak acid have pKa values then greater than the 15. Carboxylates are weaker than mineral acid, but they are stronger acid than alcohol and many phenols and ethanol. In fact, carboxylates are the most organic compound you have studied so far. You already why phenols are more acidic than alcohols. The highest rate of the carboxylic acid are compared to the phenols can be understood similarly. The conjugate base of the carboxylic acid, carboxylate ion, is stable to the two equivalent resonance structure in presence of the negative charge is the more electronegative oxygen atom. The conjugate base of the phenol is the phenoxide and non equivalent resonance structure in which the negative charge is the at least electronegative carbon atom. Therefore, the resonance in the phenoxide ion is the most important and is the carboxylic ion. Further, the negative charge is localized over the two negative oxygen atom in the carboxylate ion, which is the less effectively localized over the one oxygen atom and less electronegative carbon atom in the phenoxide ion. Thus, the carboxylate ion is more stabilized than the phenoxide ion. So far, carboxylates are more acidic than phenols. In fact, the strain on the acidity of the carboxylic acid strain of the may affect the acidity of the conjugate base and thus they also affect the strain acidity of the carboxylic acid. Electron withdrawing group increase the acidity of the delocation of the negative charge by the inductive and the resonance effect. Conversely, electron donating groups decrease the acidity of the destabilizing the conjugate base. The effect of the following groups increasing acidity orders. First, then is phenol is less than the iodine, then is Br, then is Cl, then is fluorine, then Cn, then NO2, then is CF3. Is in you have to send some examples there. Directing attachment the groups such as phenol or vinyl carboxylic acid increase the acidity of the corresponding carboxylic acid. Contrastly, the decrease expanded due to the resonance effect shown below. Because of the high electronegativity or sp2 hybridized carbon atom to the carboxyl group is attached. The presence of the electron withdrawing group on the phenyl of aromatic carboxylic acid increases their acidity, while electron with donating groups increase their acidity. Action involving cleavage of the COH bond. Formation of the anhydride carboxylate or heating with the metal acid such as the H2SO4 with the Hp2O5 gives corresponding anhydride. Ethanoic acid then it forms the ethanoic anhydride. Second is the esterification. Carboxylate is esterified with alcohols or phenols in the presence of the mineral acid with concentrated H2SO4 HCl gases as a catalyst. Mechanism of the esterification of the carboxylic acid. The esterification of the carboxylic acid carbon is activates the carbonyl groups towards the nucleophilic addition of the alcohol proton transfer in the tetrahedral intermediate converts the carboxyl groups in H2 groups which being a better leaving group is eliminated as neutral. Neutral water molecules, the protonated esters formed finally loses the proton to give the esters. Carboxylic acid then form the tetrahedral intermediate and proton transfer then form the protonated esters then form the esters. Third is the reaction with the PCl5, PCl3 or SOCl2. The hydroxyl group of the carboxylic acid behaves like the alcohols and easily replaced by the chlorine atoms in the treating with PCl5, PCl3 or SOCl2. Thionyl chloride SOCl2 is preformed because the other products are gases and escape the reaction mixtures, making the purification of the products easier. Reaction with ammonia. Carboxylic acid react with ammonia to give the ammonium salt, which is further heating on the high temperature gives amide. For example, CH3COH plus minus then form the ammonium acetate and form the acetamide. That react with ammonia and form the ammonium benzoate then form the benjamide. Here to see other example reactions. Next is the reaction involves the CO carboxylic group. First is the reduction. Carboxylic acid are reduced at the primary alcohols by lithium, aluminium hydroxide or better with the diborane. Diborane does not easily reduce functional groups such as esters, nitro, halo and sodium bromohydride does not reduce the carbonyl groups. RCOH then react with the LiAlH for ethers then form the RCH2OH. Second is the decarboxylation. Carboxylic acid lose carbon dioxide to form the hydrocarbons when their sodium salt are heated with the soda limes NaOH or CaO in the ratio of the 3:1. The reaction is known as the decarboxylation. NaNaOH or CaO and hidden it from the RH or Na2CO3. Alkyl metal salt of the carboxylic acid also undergo decarboxylation or the electrolysis of their aqueous solution from the hydrocarbons having twice the number of the carbon atoms present in the alkyl groups of the acid reaction is the called electrolysis. Substitution reaction in the carbo part. First is the halogenation. Carboxylic acid having a alpha hydrogen or hydrogen in the alpha position treatment with the chlorine or bromine in the presence of a small amount of the head phosphorus to give the alpha hydrocarboxylic acid. The reaction is also known as Hall-Vollard-Zinkley reactions. H2COH then form the red phosphorus and react with the H2O. Then it form the alpha halocarboxylic acid. Second is the ring substitution. Aromatic carboxylic acid undergo electrophilic substitution reaction in which the carboxylic acid react with the deactivating metal directing group. The however do not undergo Friedel-Crafts reaction because the carboxyl group is deactivating and their catalyst aluminum chloride is Lewis acid get bonded to the carboxyl group and form the metabenzoic acid or metabenzoic acid. Use of the carboxylic acid. Methanic acid is in the rubber, textile, dyeing, leather and electroplastic industries. Ethanic acid is used as solvent and vinegar in the food industry. Hexanidide acid is used in the manufacture of the nylons. Sixters is the benzoic acid used in the perfumery. Sodium benzoate is used in the food preservative. Higher fatty acid are also used in the manufacture of the soaps and detergents. Thank you.